in case of multiplication of two vectors, we have two types of multiplication. One is scalar multiplication and another is vector multiplication. You should keep the vector sign always to distinguish that this is a vector. Two types of multiplication, one is scalar multiplication and is vector multiplication. When we have scalar multiplication of two vectors, we have a scalar quantity, and when we have vector multiplication of two vectors, we have a vector quantity. This is very vital. The definition is very simple. OP1 we represented as x1 I cap, y1 j cap, z1 k cap, dot x2 I cap, y2 j cap and z2 k cap, and that comes out to be x1 x2, y1 y2 and z1 z2. You can easily follow. We just multiply component wise and we get the scalar quantity. Just see that this is a scalar quantity, no I cap, j cap and k cap involved, and we have OP1 dot OP2 is equal to this. And a very simple corollary from this definition is that OP1 square will become OP1 into OP1, and that will comes out to be x1 square plus y1 square plus z1 square. Obviously, it is the length of the vector, as we all know, isn't it so? Modulus of OP1. This is a corollary of this. So, scalar multiplication is defined to measure the length of the vector. And what about the cross multiplication or vector multiplication? This we define with help of matrix, and we put I cap, j cap, k cap, the three unit vectors in the first row. Then came the components of the first vector, and then came the, sorry, this is x1, y1 and z1. I erroneously write x1, x2, x3. I am sorry for that. OP1 has component x1, y1, z1. So, in the second row comes the component of OP1, and in third row come the components of OP2 vector, and we have defined the cross multiplication or vector multiplication of two vectors OP1 cross OP2. This we can easily calculate.